Okay, before the break, we were kind of taking our first pass looking at Unity, a quick tour of the interface. We're going to spend the next 4 weeks looking at it. So, uh, but wanted to kind of walk around, point towards things. That way, hopefully, you aren't completely lost over the next couple weeks as I refer to buttons and different things. Buttons and different panels or windows on the user interface, you'll know what I'm referring to. And right before the break, we downloaded some assets and should have those in our game now. So we're going to close out of the package manager. And yeah, so now it looks like there's a lot more stuff here in the assets folder. There was just one in the assets window. Sorry, I'll go ahead and close the store. I have some stuff to work with. And yeah, the reason I switched my mind, I started to go with a new one, but then I thought, well, there's actually a good point from the one from the other day that I'd like to make. Right now, well, it added a folder, so we have some stuff in there. And let's start looking for stuff so we can throw it in our game and start making something. So we start expanding this folder. There's a lot here. There's a whole lot of other folders. In the backgrounds folder, we have several different versions of backgrounds and different formats on everything. And our character, which I guess that's another one. We're not going to use this character. We start looking and things are already animated. We'll see how to do animation soon and stuff, but there's lots of stuff here. Treasure chests, different formats, updated versions of them. And a lot of times when we download a package, it's everything we might need for a game. Like the artist started creating things for a game and maybe they used something else on the game they had in mind. And the asset store is a place where artists can sell their work or give things away for free. So like that first package, there was just a couple things in there. So that was probably like a free sampling. There's those couple things, but then related to it is for like $3 or $4, probably really cheap, is a whole bunch of other assets that fit that artwork and that style. And a free sample of that artist's work. And other ones like this are just huge folders with lots and lots of things that we can work with. Like here, there's platforms for autumn or spring, and we have different artwork, different versions of the same thing. So a lot of times if we download a full package, a full package of assets from the asset store, there's going to be a lot to work with. So in general, for class, to hopefully help prevent getting lost in the big pile of assets, I'll kind of stick with what we've already been doing and just have a couple, maybe even reuse some of the ones we've used. That way we don't have a whole lot of extra assets and things to dig through, and we can focus on the point we're looking at for the particular lecture. Or we might download stuff from the asset store a couple times just to have some better artwork to look at while we put our games together. Either way, the graphics hope everybody realizes that by this point, the graphics are irrelevant to the coding. Right? We could do this all with square boxes or cubes if we're in 3D. Some people really prefer that. So then we don't end up with that issue where bugs can hide in our game because we were distracted by the pretty graphics. That's a very common thing that happens with humans. So simple images are better to work with. And yeah, one of the things I went back to the one I used the other day because I knew it was a full package, and you see there's a lot there. So it'd be easy to get lost in that if we downloaded something like that and then tried to use some of those assets for the class lecture. There's a lot of digging around just to find the stuff that I'm pointing at or whatever. So we'll start here with the background. By default, there was a camera here already, but we could, right, if that got deleted, we could add another camera. I usually come over to the hierarchy scene and use the add buttons here. Just add a camera, user interface, add video player, audio, effects, 2D or 3D objects. A lot of different things. We're going to be looking at this for a couple weeks, just kind of getting started today. We have a camera. So for a simple 2D thing to look at, starting to hopefully get a feel for it, hopefully starting to not be nervous about how big and complicated the interface is. I guess that's the point for today. Just take it a little piece at a time, make a game. I guess the first thing we might need is a background. So here in that asset pack, there is a folder of backgrounds, several folders of them. I'll just go in this first one. Different formats. I'll just use the Bing image. And then different sizes for those. Why is there more to that? So that's set up as a tile. Then whenever we find the asset we want to bring it into our game, there's a couple ways. The easiest way is just to click and drag over. We click and drag it over to our spot. It's going to throw it in the game. And that intro video came out right after they did added some really fancy layering features. So the video talks about different layers for doing stuff. What I usually do, even in 2D, is use the transform because we have that third axis. So I'm going to start by going to the camera. There's what our camera can see. I move that out of the way and go back to camera. You can see that the camera picks up part of the scene. So we have a little preview, or we can go over to the game tab and see what the camera sees. Why is my little outline not there? There it is. So I had this collapsed. When it's collapsed, I don't see the little box. So I'll expect the camera selected, not the best color for that. And over the inspector, notice the position, rotation and scale is no rotation, a scale of 1, and that's a scale factor. That means the size it was created at times 1. Nothing changed in any direction. It's at the XY origin, which is probably where we want the camera, at least to start with. That's where it's centered at. But notice the Z is at -10. So for the camera and backgrounds, I like to start with that Z axis. So negative in Unity, the negative is towards us. Or when we're in 2D Unity looking on the Z axis, the negative is going to be towards us and the positive will be away. So how I usually like to set it up is I'll set the camera at something negative. -10 will work because everything's kind of flat here. And then on the background, you can set that, center it there on the XY because we're looking at it in 2D. And then I'll set the Z to +10. So our background is at +10, so that's away from us, and the camera's at -10 towards us. So then all our action can happen right there in between them. So then everything in the game can just happen at a Z of 0, and then it's between the camera and the background. Or we have a couple other numbers we can play around within there. They're floating point numbers, so there's actually lots and lots of numbers between -10 and +10 if we want to layer things and have our character to be able to go in front of some stuff and behind other stuff. And the Z-axis is really kind of the easiest way to control that. There's the built-in layers. Those are in the video. Y'all can see that if you prefer to work with that. But especially getting started out, we don't want to dig too deep into the fancy features. We'll start with just the basics and then we can add the fancy features later. I have a big list of fancy features after we talk about the basics. And we're going to be talking about this for 4 weeks. So I guess the next thing, first thing to notice is the camera here. The box for the camera is a little bit bigger than our background. So I'm going to kind of drag that, grab these little corners to drag that around so that the camera and background are the same size or about the same size. Obviously it won't be as bad if the background is bigger than the camera side, the camera view, but if the camera doesn't pick up the entire background, that could be a problem. So we have our camera and a background. If we want to focus on something, scrolling will zoom in and out, and it does zoom to where your mouse is. So if you put your mouse in different places, scrolling in and out will change how you're seeing it. Clicking the scroll wheel will get your panning. I didn't bring a regular mouse in, so I'll do the Alt click, just the normal for the touchpads. The Alt click is equivalent to clicking the middle mouse wheel. And when we get to 3D control click and drag, we'll do the rotation stuff. We also have controls up here for it. The hand tool, that's going to be your panning up and down, left and right, just drag it around. The move tool, this actually moves our background. That's why I grab the X and drag it over. You'll see the X coordinates here in the transform changed. So I'm going to type those back at 0, 0. Then rotate, like the move, that has to do with our background here. So grab one of the little wheels and spin that around different directions. Control Z or Command Z, depending on which system you're on. The normal undo. I'm on a Mac, so Command Z, but on Windows, Control Z is undo, and Control Y on a PC is redo. It's different on a Mac, and I can't remember what the redo button is. But whichever one, we have those controls, have the things up here, we can scale it, get the corner tools, the editor tool, different ones. I'll just use this tool. I'll leave it there. Another way, if you kind of, this will be more useful when there's a lot of stuff on there. If you want to zoom in on something, look at one thing in particular, you can click to select the object and then push the F key. And that brings that object into focus. That'll center that object on the screen and kind of try to fill it up. There's a lot of moving around. That's the sort of stuff you're going to just kind of click around and get used to. Well, we got our camera and a background in. So now we need some stuff to happen in front of that background. I'm going to put something here. In this particular asset package, the character, they only have the full animations. So I'm just going to grab one of the random objects. I'll just grab a chest. That'll work. So if I go in the folder of pings for the chest, should be a little treasure chest object here. Yeah, that'll work. We can drag this in and get us an object to work with. We're just looking at the basic tools. So we'll talk about animation soon. So I didn't want to bring in the fully animated one just yet. Just any random object to see. So once again, we can just drag it in there. I guess I could have done this. Alternatively, we could drag it over to the hierarchy chart and drop it in there. Or another option is if you right click and create a new 2D object, you can create an empty object, and then add that image to it afterwards. Depending on how you want to set it up, there's different ways. But once it's in there, again, you push F to bring that object into focus. If you want to see just that one. Oh, that worked a lot better than when I did that on the background. So yeah, just the letter F for focus, or full, however you want to think about it. It makes it so you're looking at just that object. And scrolling zooms in and out, and clicking the scroll wheel and moving around, which if you're like my setup today and the good mouse is in another room somewhere, Alt click and drag is the equivalent to clicking the scroll wheel. That gets us an object in there, and well, a lot of the basic setup stuff is there. So we can just hit run in the games and see something happen. Well, see the images. They're not doing anything yet. But there's our run button up there, and we'll see it takes a minute. It has to compile all the files. It's not an interpreted language like Python. It does have to actually compile the code and get it ready to run. So sometimes it takes a minute. You'll see we jumped over to the other tab, and this is what the game looks like. We see the background and the little treasure chest. Not doing anything yet. And then you click the run button again to stop it. And that's an easy one to forget, because if we try to do stuff while it's running, it won't quite work. So hit run, give it a second to kind of get going. And it's a machine. It doesn't, it's not intelligent. It can't figure out that there was no changes there. So it had to recompile all the files and get it ready to run again, just like it did the previous time. Notice, can't drag it in there. If I come back over to the scene and try to drag it in, it kind of worked, but the game is still running. So you want to make sure and stop the game before you go and make changes like that. Now deleting this object isn't working. I was able to add it, but y'all probably can't hear that. It's just making the sound when I hit the delete button, because the game's still running, so I can't get rid of it. Oh, and when the game stopped, it's not even there. So it was like a temporary addition to it. So make sure you stop the game before making changes. And if you're on the wrong tab, notice it won't let me drag it in looking at the game tab. You have to be looking at the scene view to drag your objects in. So what's a good first start? What else do I have here? Z-axis, Y-axis. So drag that in, and if I click on it to select it, which we can click here, or in general, as we get more and more things in our scene, especially, it gets a lot easier to click on things over in the hierarchy view. And we can select it here. And now you'll see we have a bunch of little things show up in the inspector, all the stuff for that object. The transform, so we could manually type in a position, so like -5, 2.14, I'll change that to just a nice even 2. You see, you manually type in the numbers if you'd rather do that. Any rotation or angles. Some stuff about rendering it. We don't need to worry about that for now. We'll talk about some of that stuff before long. But for the most part, Unity doesn't have a whole lot of graphics creation stuff. They put their focus on the game stuff, because there's a lot of really nice graphics creation stuff. They have some, but it's kind of minimal. And they focused on the game stuff, so they integrated with some very popular ones. So like a Blender file, we saw Blender. You don't have to do a fancy export and a whole bunch of setups and adjustments to bring your stuff from Blender into Unity. You can bring the entire Blender file in, and Unity will pull out the parts it needs and handle any conversions and all of that. So typically we don't do a whole lot of the graphics editing in Unity, but yeah, they lean towards focusing on the game because there's really nice software for editing graphics that already exist. They didn't need to reinvent the wheel, to refer to that old saying. So I guess the first thing to do is might want some physics to apply. That's something we want in our games. We need physics so that these objects count as solid things that can bump into each other and fall under the pull of gravity and all of that stuff, which fall under the pull of gravity is sort of the default. And you'll notice there's nothing in the inspector about the physics, so we have to add that. And if there's this fuzzy finder here, we can go look around for stuff, physics 2D, dig through. There's colliders, effectors, joints, lots of stuff. What we're looking for is rigid body 2D. It's a lot more effective to just start typing it. It's call them fuzzy finders. So it's better than just the exact match. It's not a full-on search engine, but it does have some fancier searching things than just an exact match on that text. So we want a rigid body 2D. The general ones are for 3D, and then all the 2D stuff will explicitly say 2D. And that brings in our physics. If you've had a physics class, you might recognize some of these words. Dynamic has to do with motion and stuff. Kinematic is the fancy word that means movement. That's how we study moving things. Study of moving things is kinematics. Static is the stationary things, like the walls in your house are static. They're not moving, but there's lots of forces applied to them and things like that. We could apply enough force that they don't remain stationary. So I'll just leave this as dynamic for the body type. Then a lot of different options. We can set up materials for it, give it some sort of mass value. As your games get fancier and more realistic, you might want to try to be accurate on the mass. That is, it's a very good physics engine. So if you just left that at a default 1 and something simulating an 85 kilogram human bumping into a 1 kilogram empty box, would not look right if both of them, if the computer thought both of them had a mass of 1, right? Because a big human bumping into an empty box is going to knock the box a long way and barely move the human. So as your games progress, you might want to consider numbers like that. For starters, the default's probably okay. It has a gravity scale of 1. We'll just leave it there to start with. Constraints might be useful. The example we'll pulled up here, the object I grabbed is a square box. So that's going to be have a nice center of gravity in the middle of the box. It's not off balance. So but some things will be off balance, right? Most of your characters, if they have like a character that has even a roughly human shape, is probably going to be off balance, just like we are, prone to falling down. So you might want to expand constraints and click the freeze rotation so that your character doesn't start doing backflips when it bumps into stuff, things like that. We will see that stuff before long. For getting started, the defaults are probably okay. We'll just leave it as a dynamic thing. It'll move. Gravity's pulling on it, which means our game is going to do something now if I hit run. There's at least gravity, so the box should fall down. And we have to consider physics with our games here. Our collisions aren't simple intersections of two boxes like we saw earlier. That stuff is available in the scripting language, we didn't talk about it at that time. But our collisions aren't going to be simple two boxes trying to be in the same place at the same time. We'll have to follow the laws of physics. But you saw something happen now. Physics applies to that. It has a mass. We're in a little simulated world, so gravity's applying, so that thing falls down. As the next step is we probably need something for it to fall on. That way it doesn't just fall forever. I don't want to use another box for it to fall on. What else do I have here? Environments, what's in there? Trees and stuff. That doesn't look much like a platform. What's under tiles? Oh yeah, that's the seasonal stuff. So more stuff under background. And whenever there's big files, like big full packages, sometimes it'll take a while to dig around and find everything you're looking for. What's in here? I think these are all backgrounds. Yeah, that's all backgrounds. There was some clouds somewhere in this package. There's character, chest, coins, demo, environments. Water animation. That's probably not what I want, but let's look. I don't know if that would be a good platform. I'll grab one of the tiles, that'll work. I thought there were some clouds in here the other day, but I'm not sure where I saw them at. What's in new details? Different things. Yeah, and that's the one thing about packages. There's a lot of stuff here, so we have to dig around and look for things. What's in here? Spring, or actually, I'll go in autumn. Use seasonal things, and I'll just grab one of these and make a platform. So these are just images. They're set up to tiles, so they line up and they all have different things, and then we can lay out an area, figure out our background and stuff. We will see tiling before long. I'm just going to grab one of the images, bring that in as sort of a platform for our thing to fall onto. And I'll just resize it, make a nice big platform. Nothing too fancy. The main thing I'm worried about, you should remember, our camera was at -10 on the z-axis, so the camera is towards us in the z-axis. We're looking at straight on the xy plane, so -z is coming towards us, and our background is at +10. So we just want to make sure everything happens in between. So all the stuff in between, like the platform and the treasure chest, I'm just going to stick make sure the z is at 0, so they're nicely in between those two. There's still another step. I'm going to go ahead and run this to, well, I guess demonstrate a couple points here. So all we've done is applied physics to our treasure chest. So gravity pulls it, and it fell. Both of them had a z position of 0. It looked like the treasure chest fell in front of the platform. And what you're going to want to do to start off with is just try different things. What if we switch the order of that? If we put the grass up at the top and then our treasure chest afterwards? It's not a good name. I'm going to right click on that and rename it as chest, just to tell what's what. But for first, we'll get started into stuff with a lot more details soon. Oh, oops, Alt click. try just making little changes and see what happens. We change the order of those. Run that again. Didn't seem to make an effect. There's a reason for that. We will see before long. I guess it has to do with importance and stuff. So our treasure chest has physics, but our platform doesn't. So once again, we'll need to come into the inspector. So select the little platform thing we're going to fall on. Over in the inspector, make sure you have positioned everything set up right, and then add component, and either search for a rigid body or the previous search will still be there. So we can just select a rigid body 2D from this. Yeah, I'm gonna go ahead and run it with the defaults like we did before. Does anybody know what might be a problem if I just hit run this way? Any guesses on something that's gonna go wrong before it starts running? We want our treasure chest to fall on the platform. We don't want the platform to fall, right? So for that, there's a couple options. We could set gravity to 0, then gravity doesn't affect it. Or an easier way is, if we don't want it to move, we can just change it to static. Dynamic is it's moving and changing, and static means it's stationary. It's not moving. So we lost a whole lot of options when we made it static. But now it still counts as a solid object. There's still another option before we can land on it. And now if I run it, and God, there's lots running, takes a moment. The platform stays stationary, but even though physics applies to both things, it didn't quite land on it. Oh, it might be a good time to do that check again. We changed something, so that's what you're going to want to start off with. Let's make little changes and see what happens. Let's switch the order again. Let's put the chest first and then the grass, and see if that changes anything in the layout. Lots and lots of waiting for things to compile. It doesn't seem to change much with the view. And really the reason for that is because they're both at exactly 0. So it looks like the chest is in front, but we're actually seeing both of them at the same time. So that's why I went with like -10 and +10, so we have lots of wiggle room. If we wanted our chest to fall behind the thing, we'd want to adjust it. So the platform's at 0, so we could say like -1 on the Z and run that. And wait again, wait. I couldn't see it very well there. It should have went behind it. Oh wait, I said -1. +1 would be behind it. Or 3, +3 is behind it. So we change that. And this is what you're going to want to start off with. We're going to get up through basic movement. Then we have that wiggle room, so things are in front of or behind. But that's what you're going to want to do. Just kind of click around on things, make changes, see what happens. You don't necessarily have to save them. Oh, unlike some of your the other stuff we've seen that automatically save when you're in it, this is not automatically saving. So make sure you hit Control-S occasionally, or Command-S, or go to the file menu and click the save button occasionally. But we applied physics so that the treasure chest would land on the platform, right? It's going to fall, but there's something else that physics applies to below it. And in order to do that, we need to define the bounds of them. We have to say where the edges are so they can collide with each other. And really for a collision, we only need it on one. Over the years, I found it's best just to put it on both, because you might need it on the other one later as well. So we have two objects here. We want our treasure chest to fall onto that platform. So we need to define some sort of collision bounds for both of them. So if we go to the treasure chest and add a component, well, there's a number of colliders. We start looking for colliders. We have box colliders for 2 or 3D, capsules, circles. We can define edges, set up polygons. For now, I'm just going to click the box collider. So I'll put a box around that one. A lot of different options we can use. We'll see some of these options. There's a lot this game engine can do, so we won't be able to see everything in 4 weeks. We'll see quite a bit. You'll want to look through there, see what some of the options are, and over the next couple of weeks, maybe develop questions as you see different things and can see what we will see. One that will be important is we might want to adjust that. The default edge might not be so good. I'll hit F. Well, it's really hard to see. It's a bad color. If I drag that over, you see there's sort of a green line. I'll drag the whole object over. I'll grab that, drag it over here. Oh, there we go. When it's not in front of a green background, you can see this green line. When our edge, when we select the edge thing, you'll see this green line has little handles that we can click and resize and sort of define where the edge of that is. And I think I'm going to bring it up a little bit from the bottom. That way it doesn't stop right on the top of the thing and looks like it's sort of in the middle of the platform or something. The edge collider, just click the edit button to toggle back and forth and set it up to the bounds that you want on it. I'll drag that back over where it was. Oops. Oh, and to the dragging I did there, I just selected it, and then that little circle in the middle is a grab point to move it around the scene. So we also need an edge defined on this. So we can do the same thing. It's a nice square platform, so I'll search for a box collider, box collider 2D. And that'll assign something. So we just check this. I guess you can see the handles a little bit better here. And just adjust it to define what you want the edge of it to be. We're going to spend a little while on colliders before long. So now both of them have clearly defined edges. Physics is applied, so the computer thinks there's solid items there. So when they bump into each other, it should stop moving. So run that. There we go. Now our box lands on that and is stationary. It's the next thing is we want a way to make it move, but I'll point us something again. The item I grabbed is just a nice square box. There's the computer's going to register that box as having a center of mass right in the middle. It's not off balance. It's something like a human shaped image. The computer's going to think that it has a weird center of gravity. So when it lands and stuff, it might start spinning weird. If that happens, just remember to come back in your rigid body, and under constraints, you can freeze the rotation around the Z-axis to prevent the spinning. And moving in 3 dimensions, you have to define explicitly freeze the rotation around which one of your axes. But again, that'll fall under just clicking around on things. Next thing, before we make that box move, I'm going to go quickly over the user interface, the UI portion, for the heads-up displays or messages, game over messages and menus and all of that sort of stuff. We'll look at it in a little more detail. I wanted to go ahead and include it today because on Monday we'll be doing a pass at the C# syntax our basic syntax of C#, just like we saw in Python earlier. So just like we did there, instead of using the console for our general syntax pass, we'll just throw it on words here. So I'm gonna come over to the hierarchy area and just add it here. So if we right click, there's these options to add stuff, empty objects, effects, different lighting. And down here's the UI components, buttons and sliders and text and all of that sort of thing. This canvas element's important. A canvas is something we can draw on. We'll need that, but I'm going to go up here and click on text, and you'll see that it created some other objects with our text. So there's the text object, I selected that, but it also created a canvas object and an event system object. We need all three of those to draw on. So if you, instead of putting them in manually, just select text or button or whatever you want for your UI component there, and it will bring in the other parts it needs with it. So there's some text we can put on the screen. And over here, sorry, transform area looks different. This position seems kind of strange. We'll see those numbers. A width of 160 by 30. Maybe that's about the size of our screen. I haven't sat down and measured it, but filled in some numbers by default, pivot values, some rendering things, and then some text objects showing what it is. Normal options that you're probably used to for editing text, the alignments, wrapping text or cutting it off for overflows, how we handle that, what color is it. We'll use some of that. Notice with it selected, we see this little corner here. Looks like it's there, but that's not really the corner of the text object. If I hit F, notice it zoomed way out. And not only that, that little corner we were seeing, we're not even seeing that whole corner. I keep scrolling out, scrolling out, scrolling out. It kind of looks like this. Notice we have that great big huge rectangle. And our scene is this little bitty thing here now. So this big rectangle represents what the camera can see. So that represents our camera area. And then we can just kind of drag stuff around and position our text like in the camera area. So I'll just, for now, just putting some text on there, and then we'll use that sort of thing to go over our coverage of basic C# syntax on Monday, which I did not plan well because on Monday in my evening class, we'll be finished with the basic Python. So then we're going to do a pass, maybe one, maybe two other languages in the evening class on Monday. So it looks like I'm going to be going over 3 different programming languages on Monday. It's like, oh, when I realized that, I thought I could have probably planned that a little bit better. Hopefully I'll remember all 3 of them without too many difficulties. But this class is first, so won't be a problem here. Just thinking about 9:30 in the evening, having gone over, worked in 3 or 4 different programming languages throughout the day, they might be starting to blend together a little bit. So put the words hello world there. Kind of hard to see, so we could change this. We have different fonts. I'm on a Mac, so the fonts are funny. Have to import them and include them and all that stuff. Have to pay Apple for them. I'll make it italic, make it really big. Change the color so it shows up really red. That'll work. The normal text editing options, they should all kind of look familiar. If I scroll in, I don't see the words there. So they were too big to fit on there. So once you get words there, notice as I resize this, it automatically adjusts it to fit. Tries to find the best fit to it. But then this represents what we can see in our scene. So we position all our UI stuff zoomed way out like this. And we can't really see it until we see what it's like, look at the game view. So our scene view looks at it different because we might need finer detail, I guess. It keeps our UI stuff completely separate. It takes a minute to get used to working with it because we have to switch back and forth between views so we can see how that's going to look on the screen. When you're ready, remember, we can just maybe select the background object and hit the F. F is in feather. Oh, and notice it's not doing anything because our keyboard shortcuts do different things depending on where the mouse is. So put your mouse in the scene window and hit F, and it'll focus on whatever's selected. Select the background object there. So now when we run that, we saw some basic physics. So our objects, the laws of physics start to apply. So we can do things like motion and collisions, things bumping into each other. And it is full laws of physics. So if that wasn't set as static, the mass that each one of those things have would apply. Did you notice it bounced? Unlike the earlier ones we saw, when a collision happens, we would just say stop moving. But here it's the full laws of physics. So if you watch carefully, you'll notice that it bounces when it hits the ground, like the laws of physics we expect. So it's kind of set up for those realistic things. Not much of a bounce there, but a little bit. And it can be controlled like everything else. We're down 255. So that was, there's one more thing I'm gonna cover here in class, but that's kind of what I was gonna suggest to start off with in our lab time today. And then this weekend, can I click around, see if you can replicate this? Like go to the asset store, find a different package of assets, or create your own, and kind of make sure you can get all those basic things going. Get a couple objects in the scene and apply physics to them. And basically just enough that gravity pulls something down to land on it. Before we finish up for today though, I did want to add some movement in, just kind of start looking at that basic one. Yeah, this would be a good way to do it. So we're gonna make this chest move just back and forth, that'll work. So if I go to add a component, maybe as you're starting out, like I'm not sure what to look for. Navigation is, that's something different. That's mesh agents. We'll see those before long. So it's not under navigation. Like maybe there's a movement thing. So if I start typing move, notice there's no, it very quickly, I didn't even get the whole word move put in. It's like movement. It couldn't find anything related to movement or the word move. I didn't even get that whole word in. And the only option, the only component it can find related to that is a new script. There's not one that exists. We have to create it. And that's because the movement in every game is unique. Over the years, people have tried a couple different plugins, and they're still on the some are available on the asset store, but every game is unique. Unity kind of doesn't even give those good results on the asset store if you search for them, because you want to be able to adjust that to fit your animations in a particular game and the setting, because that might not even be consistent across the game. It's something very unique per game, so it is something we have to script every time. So to add a script, make sure you're on the right object that you want to connect that script to, and just create a new script. And it couldn't find that thing I searched for, so that's the recommended name for the script. Or create an app. Oh, it's up here. I was looking at the bottom of the list. Now you'll see there's this new script added. So we need to go in here and work with this script. Is it trying to open? Is that what it's doing? Okay, not sure what it's doing. See this little thing here that says what script we're connected to? There's lots of those panels where things from our assets connect to. So if you're not, we can drag over to it. So we can grab one of our assets, click and drag over to drop it into that spot, which it was already here. If there was another script to drag in there, it would be there. So if that's empty, you would need to add one. But we're ready to write our script, which is done in C#. And earlier we saw the preferences where I changed it. So I said I want to open with the Atom text editor. So it should open with Atom now. Yeah, starting Atom. And it doesn't give us a blank text file. So we talked about object-oriented programming earlier this semester. C# is one of our languages that is only object-oriented. I have to change the font size to make that all fit. I'm select this and I can't remember where the font size is. That's probably a good size to type with. So we start with this much because every script has to have at least these things. We talked about object-oriented programming. There's, in particular, everything we need is included, encapsulated. But we also talked about inheritance. And we can set up some stuff in an object, and then another object can inherit all of the things from that. And then we have polymorphism. So the thing, like a child object can behave as its parent object. And we have to do that. When they set up Unity, they created a couple objects. One of the main ones is mono behavior, which is like the names indicates the single action, or I guess they're synonyms for those words. Mono behavior, that is the parent object of everything we want to do in Unity. And I'm going to change these curly braces just because I kind of prefer this format. When we go over our syntax of C#, we'll talk about the curly braces. That's one of the things on there. It imported a couple libraries for us. So using this library and this library and this library, we saw the keyword class. So what we're creating here is a blueprint for what we want. It's only an object-oriented thing. We're going to call it movement. It's public, so it can be accessed from elsewhere. We'll talk about this more on Monday. And it's going to be a child of the mono behavior object. So everything in Unity basically has to be a child of that object. So when they set up all the methods internal to the engine, they work with the mono behavior object. So then when we create a child of that object, it can be passed into every single thing there. Because it's a strictly typed language. We have to say what type of thing we have. So we can't just say, pass this object into this method, or we can't write a method and say, expect to receive something. We have to say what type it is. So everything is at least a child of the mono behavior object. So it can all count as the mono behavior object. I guess using parent-child or terminology, we could say the mono behavior, everything is the mono behavior family. So that is the type of data objects we have. White space doesn't matter like it would in Python. So we don't have to worry about spacing. Spacing is only for your benefit, spacing, indenting. The curly braces, and here very shortly, semicolons are what matters. So white space and indents and things, those are for your benefit, make it easier to read the code. First thing I'm gonna do is label these methods. So it's only object-oriented. That means we can't just have random functions to work with. The technical difference between functions and methods, we usually use those words interchangeably. Methods are associated with an object, and functions are sort of independent things. So anything that we want to happen really needs to happen inside of a method. So then we'll say like our movement object dot start. That's one that's called automatically. So start has to be there. Or we can say update. There's a couple types of updates. Update is going to happen every frame. So start happens once. When we initialize our game, when we start the scene, or when the object first appears in the scene, the start method will run one time. So that's where we initialize everything. And then the update method is what runs every frame of the game. And we have a couple different options. For now, starting off, let's just stick with the regular update method, but we also have fixed update, which happens at an exact time interval every time, because remember, our frame rate is always a target. We're not going for exactly 60 frames. We're going to try to get 60 frames. That way, if there's a lot of stuff going on, we don't run out of time in order to fit exactly 60 frames in a second, the 16.6 milliseconds. Right? If we need 18 milliseconds to carry out a particular step of the game, a particular frame, the computer would run out of time and have to move on. So we want a little bit of wiggle room. But if we want an exact time, that's a fixed update. And then we can override that wiggle room and say it's okay, exactly 60 frames every time. Don't worry about that other stuff, but that can cause little jumps. Right? If we don't need that much time, the computer is going to pause while it waits and doesn't do anything. Or if we need a little bit extra time, the computer can stretch it out. But fixed update kind of undoes that wiggle room, and it sets it for an exact amount of time every time. Update is the general one that's just going to run every frame of the game with whatever the engine thinks is the best amount of time to spend on a particular frame, which is probably what you want to go with for starting with. There's also late update, and late update will happen at the very last thing in the frame. So we're going to have several different objects, different scripts running in our games. So the things that we want to happen at the very end of that frame before we start the next frame, we would put on the late update. Before starting out, we'll just start with an update method. And in Python, we used indenting to signify what instructions to run, like in a loop or in a selection structure. In C# we'll use curly braces. So we just start here and end here, and every instruction between them goes together. And I mentioned readability. It's a good idea to label your closing curly braces. It's like the end of that one ends the start method. And forward slashes, two forward slashes is a comment. So it can just be kind of good form and very useful in case you need it to keep track of those closing curly braces. So the opening one, whether it's on the same line, like I like it here, or on the next line, it's right by the start. We can tell what it goes with. But the closing curly braces can end up a long ways away. So it can be a good idea to label those in movement class. And just set up some little signposts. We won't need them today for sure, but that's a useful habit to get into, so might as well mention it right from the beginning. So pretty much everything we want to do needs to happen inside of a method. The exception being our global variables. Usually outside of any methods, typically it's done at the top. We want to declare all our variables that we're going to have. And we can initialize them if we want to, but the things that are going to have global scope, what we want to be able to access from anywhere. So to start with, we're going to have a speed value, and it's strictly typed. So we have to say we have a speed value. I guess one thing about C# is public is implied. So our data can either be public, private, or protected, and we'll talk about this on Monday with our C# pass. Basically, public means it's accessible from outside. Private means it can only be changed from this text file. Once it's compiled, it cannot be changed if it's private. It can only be changed from the text file here. So a lot of our stuff we want to make private to keep it protected or keep it safe. Then protected is just like private, only the child objects, only protected will be inherited. Protected stuff gets inherited. Private stuff does not. So some things we want public, some things we want private. In C#, public is implied. So if we don't put the public or private or protected, we don't put one of our keywords, it'll be implied to be public. But there's an extension on that in Unity that we want to pay attention to. So I'm going to start with just a speed value. Integers, some speed equals the value 3, end of instruction. It's going to look something like that. Well, maybe speed doesn't necessarily need to be an integer. There's several types of numbers we have. We'll have a number, different types of numbers. For the most part in Unity, you're going to want to work with integers and floating point numbers. If you've encountered this software before, this programming language in other situations, like business situations, you've probably heard over and over again to use double precision numbers. But Unity is set up to work with the floating ones that don't have as many bits, because that's going to make everything faster. There's less bits to move around. And we definitely want faster in our games, right? If we have lots of numbers and we're using 32-bit numbers instead of 64-bit numbers, those extra 32 bits are going to add up with all the stuff in a game. So with Unity, it's going to be mostly floats. I'll use a floating point number. So I'm going to hit save there, and I'm going to pop back over to Unity real quick. And notice what it's doing. It's compiling it. If you're using Visual Studio to write your C# scripts, you have to wait for it to compile on Visual Studio, then come back to Unity and wait for Unity to compile it. Oh, so we got a warning, and that's what the console is. Notice at the bottom there in the status bar says the field movement or data field movement.speed is assigned, but it's never used, which that stuff also shows up in the console. It's a yellow sign, a yellow symbol, not a red symbol. So one of them we can ignore. And I did that for a reason. We come over here. Here in our script, you'll notice there's still nothing special. It just says the script. What script we're using, it's already expanded. That's everything there is about the script. So that other point I wanted to make, I come back over to Atom. The language C# public is implied. We can state it explicitly. And if we explicitly state that it's public, our speed is a public floating point number with a publicly accessible, which means other software can get to it, because other software is interacting with this software. So it's not necessarily public and private in terms of other people, right? Other software needs to interact with this script we're writing. So other software can interact with it. It's public. There's enough room on the RAM chip or chips to keep a floating point number, which has less bits than the double precision that we would usually use in business situations, because games get very, very large very, very quickly. So we want to save those 32 bits every chance we get. So floating point numbers in Unity. We're going to call it speed and assign it a default value of 3. Might need to adjust that later. Actually, I could have left off the default value. Now I'm going to come back over here, wait for that to compile again. And notice what happened over here in our inspector. Now, after adding that keyword public in, there's a text box here we can type into. It's like, we don't want the speed of 3, we want the speed to be 5. And that will override what's in the text file. I'll just leave it as 3 for now. It will change back to what's in the text file at different points. But when we make them public, we can access them from our interface. And that can be very, very useful, especially if we're trying to figure out what speed we want, because we can change it while the game's running. Once we're doing something, we'll see that. Let's see, I'll go back over to Atom. And in order to move, we need a reference to the thing we want to move. And that one is our object. We don't need other software to access it. It's like, okay, we want to make sure that data is safe, so we're going to be selfish with it. We're going to call it private. It is only accessible from this text file. Once this compiles down to machine language, there is no way to get at this variable, is what private means. And our object, you might remember, in order to get the physics to apply to it, we had to say it was a rigid body, or in particular, a rigid body 2D. So that's the data type we want to refer to our game objects, a rigid body 2D. Oh, and I have predictive text turned off. If you're in a regular text editor, it will, the predictive text will show up. That comes from the language, not the editor you're writing in. So those little predictive boxes that show up, it comes from the language. So I turn it off in a lot of class examples. I thought it was turned on in Atom. That's why I switched to using Atom. But apparently it's turned off. But normally you type like that munch, and then you'd see that whole little box there to choose off the list. Oh, whoops. Yeah, I'm going to type that wrong. I did type that wrong, so a difference from the list. But I like to look at error messages and see what they are. And then body. And so body is just the name. Then semicolon means end of instruction. So declare a public variable with floating point data, call it speed. The public means we can get to it from our elsewhere, like our user interface. Give it a default value of 3. Then we're going to declare a private variable. Be selfish with this variable, nobody else can access it. It's rigid body 2D type of data. We're going to call it body, but we need to get that from our game. So we can't get that until the game starts. So that we have to grab from our start method. So the start method runs one time when the object first shows up in the game. So that is where we initialize everything. We'll go ahead and set it up. So we'll set that body to have a value of something we're going to type a lot in Unity. Get component. And we need some angle brackets, and like the get implies it's a method, so then we need parentheses for the method, and then end of instruction, the semicolon for end of instruction. Has anybody typed a language where we use angle brackets before? Actually means the same thing as it does in HTML. It probably just wasn't explained there. Okay, so angle brackets indicate what type of thing we have. This is a strictly typed language. We had to say we had a floating point number. We had to say it's rigid body 2D, which you can probably already guess there's a typo there because it didn't change to the color for data types. But I like to look at error messages and examples. It's supposed to be a lowercase b is the problem, but I want to see the error message. I figure it's more useful to know how to address certain issues when we see the error messages. But we have to say what type of data we have. And this get component was written with what's called a generic. They used angle brackets and just put it in usually like a T or an E, stand for type or element, something completely generic. It's like, okay, we're going to write this method, but we have no idea what people are going to use when they go to actually use the get component method. So inside of that, we have to have a an explicit type of data, a concrete thing. In our case, it's rigid body. I'll put the typo there as well. There's a typo there, we'll come back and fix that. So we're going to get a component of rigid body 2D type data, and that's what this variable is going to hold. And before we go further, I'm going to go look at the error message and this. So we saw Python earlier, and I think at that time everybody had said they'd seen Python before, right? It's an interpreted language. We run the first line, take the first line, translate that into something the machine can deal with, run that, then come back, grab the second line. And we can do that one at a time. We don't look at the whole thing. C# is a compiled language. So it takes all of these instructions and turns them into machine code. So that's what we have to wait for over here. It has to compile into an entire file of instructions in machine language. And there's red down at the bottom, but if you were in a hurry and didn't notice that, if we hit play, compile, that message pops up. All compiler errors have to be fixed before you can play the game. And the console here will tell us what it is. There's a problem in the assets folder, the movement.cs script. The type or namespace rigid body 2D could not be found. So there's a typo in that name. It's one word, so lowercase b. So I'll go ahead and fix that. But a common error, typo error, that's what the typo error looks like. Namespace name is what you'll see. If you see type or namespace name, that means there's probably a typo. Oh, now it looks like all those error messages went away. We have this little box for our public data, so we can change it from our interface and not have to go back to the script constantly. So the things you want to be able to adjust like that. Once we're actually moving, we'll see that. So now, how do we get this to move? Right? We just want to use our basic controls, and a lot of those are built into the game. So that's the thing I mentioned earlier. If we go up to the edit menu, there's an option for project settings. And this is something that often needs addressed everywhere. In particular, there's lots of different things: adaptive performance, quality of the thing, tags, layers. We can adjust our physics, get fine control over our physics engines in both 2D or 3D. But our movement is probably going to happen with a key press, an external event, an input. So under Input Manager, you'll see, well, here on mine, everything's collapsed. But this is where you can configure the controls to use with the Unity engine, .input API. API stands for Application Programming Interface. It's our programming languages, basically, the libraries in our programming language. Consider using the new input system package instead. We might look at that at the end. Any tutorials reference, that's brand new, 6 months old, 6 months out of beta testing. So you might find a couple things, but pretty much every tutorial you'll find online reference is going to go with the old system. So especially starting out, we don't need to jump to the new system yet because there's not going to be as much support for it. We have axes. And if we expand that, we're right at the top, you'll see a couple things that you're used to calling axes, or an axis, a horizontal axis and a vertical axis. That's what we want to move it. But you'll see these other things. There's a fire axis and a jump axis. That has to do with vectors. Remember we talked about vectors earlier, and everything can be treated as a vector is essentially a collection of numbers that go together, and they can be treated as one thing. We're familiar with, most familiar with vectors in like 3D space, where we can think of it as like an arrow. instead of a point sitting on our XY plane, we're going to think of the arrow that goes from the origin to that point as a vector. It means the same thing as those collection of numbers, but everything is going to be a vector. So where they say axis, instead of like our x-axis, it's the x dimension and the y dimension, or horizontal dimension and vertical dimension. So we'll just move this horizontal to start with. So I'll expand that. And the important one that we're going to need here is the name of it. Notice it's named horizontal. And then we can see different things. So the negative button is the left arrow, and those refer to the arrows. The positive button is the right arrow. Alternatively, the negative button, we could use the A for left and D for right. So the defaults are usually what you're familiar with. If I scroll down a little more, we'll just move this left and right, but maybe our jump dimension or jump axis, it's the name is jump with a capital J. Obviously we can control that, but that's a good name for it. The positive button is the space bar, how much gravity is applied to it, different things, and we can control the joysticks we're coming from and things like that. So if you want to stick with these, is that way whenever if you set it up for the keyboard, like this is saying the A and D left and right, but if I was to plug up an Xbox controller, that would change. Because obviously the game engine is going to expect that if there's an Xbox controller plugged into the laptop, that's what's going to go with the game. So if we stick with these built-in axes, and the main thing we need for our script is what it's called. This is named horizontal with a capital H. If we stick with those, then changing between inputs, we don't have to make any extra adjustments for. The really, really good programmers that work at Unity already took care of that for us. So we can come over here and just ask for that axis. So I'll do that in the update. So in the start, well, we just need a reference to the thing we want to move, that rigid body objects, physics apply. And then the update, every frame of the game, well, we want to check that. And I have this method built in called input. There's an input object that we can use that has the option get axis method built into it. So then parentheses, end of instruction. There's a couple more things. Is which axis do we want to get? So any of those that we just saw, the horizontal axis, the vertical axis, the jump axis, the fire one axis, we just pass in the name as a string. So I'll just grab the horizontal axis. That'll get us the value of that axis, which is a floating point number somewhere between -1 and 1. So once we get that, we need to put it into a floating point data value. So float, I'll just call it HOR, abbreviate horizontal. So float horizontal, a floating point number somewhere between -1 and 1, which on my keyboard, it's either going to be -1, 0, or 1, depending on if the A key is pressed or released, D key is pressed or released. It's going to be one of those values explicitly, but y'all know some things are a lot more sensitive. Some of y'all's machines, you might have a gaming computer where it's not just press or release the A key. And there's the sensitivity on those keys so that you have better control over your games. That stuff's built in. But we use the input, get access, and ask for one of those inputs that is built into the Unity. And it's going to give us a floating point number, and then we just need some sort of reference to it. I'm going to abbreviate that differently so I can read that word. So a floating point data called HORI, just an abbreviation on horizontal, horizon. I might as well spell it out. No need to be lazy with typing. a floating point number called horizontal that is just the current value of the horizontal input axis, by which I don't have an Xbox controller plugged up. So right now it's the keyboard, the A and the D key, or the left and the right arrow, or could go in that box we just looked at and change it. And then we need to change this. Has anybody had a physics class before? Like Physics 101? So if you're considering game development, you're probably going to want to take a Physics 101 class. And everything in Unity is set up as Physics 101, sort of kinematic motions, all the references and names. So one thing, speed, I use that word up here. Speed is just a number by itself. And with physics, everything applies with vectors. So speed isn't enough. We want to know speed in which direction. Because 3 pixels going to the left is different than 3 pixels going to the right. So we need velocity, which is the vector version of our rate of change in position. It has direction and a magnitude. It has 2 parts so that we know how fast to move and in which direction to move. And that is built into this rigid body thing that has all our laws of physics. So we can ask for that, the thing we typed in, that stored in this variable called body, and we can say dot velocity. And there are different components to it. And we're going to assign that something. And velocity is a vector. There's multiple parts to it. So we have to assign, if we want to assign a value to it, it has to be a vector. So we'll do a new vector2, and then we'll pass in the parameters for the vector we want to assign that to. The first one is, well, we just need the XY here. There's different ways we can create the vector. So to try and simplify this first pass at it, we'll just use the XY creation of a vector. So much in the X direction, so much in the Y direction. It'll figure out what our angle is and everything from that. But from this intro example, all we're doing is a horizontal, which we have a speed. So we want our X value to be that horizontal times that speed variable we set up here, and can change from our interface. So that'll give us an X value. Whatever we're at, we're going to change it by that much. And our Y value will just keep the same by referring to that body again, that rigid body object. It has a velocity, and that velocity has already had a Y component. So the dot operator is used to indicate something about the data object we're looking at. So the body object, which is a rigid body thing, has all our laws of physics, including stuff, it has information about velocity. And then that velocity has different aspects to it. It's a vector, so it has at least an X and a Y. So we'll just keep the Y right like it was and change our X. That makes sense? Anybody have any questions? Can I close it? There we go. That way all the words fit on the screen. So that's the starting point for making it move. And making it move is always unique. That's going to be unique for every single game. So this is the basic idea. We grab one of our axes, create a vector that involves some sort of speed, and just adjust our X and Y axis by that speed. And when we get to 3 dimensions, the X, Y, and Z values. That's very, very similar. Okay, if there's no questions, I'm going to jump back over to Unity and compile that. And Unity has a compiler. If you're using Visual Studio, you have to wait for it to compile twice. I have encountered things where the compiler in Visual Studio is the one set up for Windows, whereas Unity is a cross-platform compiler. So I have encountered things where they're not in agreement, but it's certainly not anything we'll see at the introduction level. Issues like trying to do things different for a PlayStation controller versus an Xbox controller. They're not the same controller. I don't want to run the same code for both of them. But and the Windows specific thing didn't like the cross-platform version. That sort of stuff. So definitely not anything we're going to see in this class. But now we have a speed. We can adjust from this box. That script is connected. Here on the console, we don't have any error messages showing. We'll go ahead and run the game. And those basic arrow controls should, whoops. I was expecting a little circle or something. I thought I hadn't clicked that yet. There we go. So it falls down. And now the arrow is moving back and forth. And if you click somewhere else, you might want to click on the game area to make sure that window has focus if your controls aren't working. But that finishes up the basic pass we had in mind. Oh, and then it's really nice to have these boxes because we can change that as the game's running. So I can type another number and then come over here and click to make sure focus is here. You can see now that moves a whole lot quicker. And notice it doesn't just stop. It's regular laws of physics, so it's in motion. It has momentum, so it has to wait on friction to slow it to a stop. Jump right off the edge. And there then you can see it was kind of spinning on the way down. We're gonna spend the next 4 weeks at it. So that was the first quick intro pass. I think that was everything I had in on my list. Yeah, for class, make sure you click that button for the free filter on game assets. Don't need to spend money for this class. The textbook and tuition. But that's kind of a given. You don't have to spend extra money on the stuff for the labs and whatnot. Background, objects. Okay, yes, that is everything on my list. So you might want to just start playing around with it. See if you can download some assets and duplicate that minimum amount. Get your objects or probably characters instead of quickly grabbing a box because there's an image to find. Get your characters standing on a platform moving back and forth with a simple script like this. And I will send that script out right after class. Does anybody have any questions? I'm guessing no, because this is an active subject. Questions are going to show up when you're doing stuff, right? Your box lit up, Andrew, but you're muted.
Oh, I was about to say I don't have any questions.
Oh, okay. Yeah, it's an active subject. The questions aren't really going to show up till you start doing stuff and then get stuck at points. But y'all know the routine by now. Text messages and Ivy Learn messages make noise on my phone. As always, I will be sitting here until 4:50, our scheduled time. Then we head up to campus for my evening class. You can ask me questions anytime. Give that a try. Just click around the interface, look at where buttons are, because we're going to spend the next 4 weeks on that. So as we go through lecture and stuff, you might want to follow along and have some sort of idea of the different panels and different places to click on and stuff. But just kind of a basic start. Otherwise, that was what I had on the list for today. I guess I will see you all on Monday, and we will start on Monday with our pass on the C# language, our quick pass at the syntax of the C# language. See how to put a script together for that, because we will definitely need it over the next 4 weeks. Y'all have a great weekend. I'll see you on Monday.
All right, see you, Chris.
Good weekend.
Have a good weekend.
You as well.
Oh,